Right. So the standard approach for witnessing or not witnessing, just quantifying a quantum advantage is typically through complexity, and in communication and networking scenarios is called communication complexity. And what you look at there is how many communication resources, meaning how much entanglement, how much shared randomness, how much classical communication, and how much quantum communication are needed to solve a problem. So typically the approach is you would have a problem that you want to solve. In our case, one example might be you want to solve this random access coding task. And we then ask how much quantum resources are needed to solve that task and how many classical resources are needed to solve that task. And you can compare the two numbers. Now, this approach has been studied very heavily, and there's really great advantages that can be found through communication complexity. However, the biggest challenge is that most advantages are only show themselves when you have like hundreds or thousands of qubits of communication, which is not a system that we can build right now. So we kind of flip this problem upside down and say, here's a quantum behavior that we can produce using quantum resources, and we know exactly what resources we use to produce that behavior. And then we show similar classical resources cannot reproduce that behavior. And what that shows is that there is a communication complexity advantage. Your task is to simulate the quantum behavior, and you have the quantum resources that do that perfectly. And you show that your classical resources are insufficient and that you need extra. So that's a communication complexity advantage. And the benefit of using non-classicality to witness your advantage versus communication complexity is that non-classicality is witnessable in classical data and observable even in the most minimal resource configurations. As I showed earlier, all you need is a single qubit of communication to demonstrate non-classicality. There is no communication complexity task that I'm familiar with that can be demonstrated on such a small scale.